Hi there and welcome to another video from Hegarty Maths. It's our sixth and final video on factorising quadratic expressions, and in this video we're going to do the hardest type of factorising, so you really need your wits about you for this video. Let's start by showing you the type of things you've already factorised. Hopefully you'll be able to factorise the following two examples, so pause the video and do that for me. So hopefully you could do these two questions and you got the following answers. How did you do them? Well, in this case here, when trying to think of the two brackets that this expression factorises into, you had to think of two numbers that multiplied to positive 12 and added to positive 8. They were 2 and 6, so x plus 2, x plus 6 were the two factors. And in this one, well, just before you launched into it, you were to look at the coefficients in front of the x squared, the x, and this number here, and you would have seen that there's a common factor of 2 in each of those. Factor that out, step 1, and then factorise the quadratic expression left over into two brackets, and you would have done. Now what we're going to do in this video is questions of the following kind. Now what's different about these? Well, firstly, it's got a number other than 1 in front of x squared. It's got a 2 there, but this one had a 2. This one was much easier than this one because there was a common factor of 2 in each term, so we could have factored that out. But here 2 is not a factor of 11, so we can't do that little trick, and we have to think of a way of finding the two brackets that when multiplied out gave you this. So that's what the big idea for this video is. In order to do it, it will really help us if we can expand double brackets like follows. That's the key to unlocking the pattern for these particular types. So pause the video and expand the following two double brackets in part 1 and part 2. I really hope you could get the following answers. Now this bit is the key bit here. The type of questions we're going to be asked to do in this video is someone's going to give us an expression like that and going to ask us to tell us the two brackets that it factorized into. So we're going backwards, okay? But in order to go backwards, if we understand the actual expanding process, it's going to help us immensely. And there's a little trick here that I can point out to you. It just so happens, you see this 11 here, when we expanded out and we got plus 8x plus 3x and they combined to plus 11x, that 8 and that 3, right, they add up to that 11. But there's something special about that 8 and that 3. If we do 8 multiplied by 3, we get 24. And it just so happens that is always the same answer as this number multiplied by this number, the 2 multiplied by 12. The number in front of x squared multiplied by the number on its own is 24. That is just always a truism. In case you don't believe me, let's check the next example. Now this positive 6 and this positive 4, they combined when we simplified to the positive 10x. But look what happens. If we were to work out 6 multiplied by 4 is 24, right? It also is true that 8 multiplied by positive 3 is 24. And that is a pattern that always works. So this is going to be absolutely super useful to us. If someone asks us to factorize that, what we're going to do is we're first going to do 2 multiplied by 12 is 24. And we know the two numbers that add up to 11x must also multiply to 24. We know that from what we've just talked about. So we're going to look for two numbers that multiply to 24 but add up to this 11 here. And I can think of those two numbers straight away. I know that they're 3 and 8. And that's going to be the key to unlocking this factorization. So let me just do one for you to start. Let me do that very example so you're confident. From what I've just told you, you know the two numbers that add up to 11 will also multiply to the same answer as 2 times 12. So the first thing I'm always going to get you to do is do this number times this number. 2 times 12 is equal to 24. So let's look for two numbers, these are our search, two numbers that multiply to 24 but add up to 11. Can you think of two numbers that do that? I can, 3 and 8. What you're going to then do is you're going to rewrite the expression that you're dealing with, and you're going to break that 11x up into 3x and 8x. Now it doesn't matter if you write the 8x first and the 3x second, it doesn't matter at all. So let me just, why don't I write the 8x first? It doesn't matter. So I can write this as 2x squared, add 8x, add 3x, add 12. Now what I'm going to do is this little technique is called factorising by grouping, by the way, if you look it up in textbooks. What we're going to do is we're going to factorise this bit separately and factorise this bit separately. So, common factor of 2 and 8 is 2. A common factor of x squared and x is x. I can factorise out 2x and I get in brackets here x add 4. Let's do the same on this side. The only common factor here is 3. So 3 goes into 3x and 3 goes into 12. So factorise out a positive 3 and I'd get x add 4. When I do this technique, it is always true that I get the same bracket here. And we are on our way to having factorised this. If there's an x add 4 there and an x add 4 as a factor there, x add 4 is a factor of both and I can factorise it out. What am I left with? 2x add 3. Because x add 4 times 2x is 2x x add 4. X add 4 multiplied by 3 is 3x add 4. And that's it. The factorisation is done. Can you believe it? So I should have had my identical signs in there. Now I should possibly show you that if I had written the 3x there and the 8x there, it still would have worked. So I better show you that as well. If I had written 2x squared, add 3x, add 8x, add 12, it still would have worked. So it just shows you it doesn't matter which way around you write it. If I factorise these separately, the only common factor here is x, and I would get in my bracket 2x add 3, and the common factor of 8x and 12 is positive 4, and I would get 2x add 3 again. Now in this case, the 2x add 3 was the same here and here, so I could factorise out that, or factor that out, and I would have 2x add 3 at the front, and what am I left with? X add 4 is my second bracket. And as you can see, that's identical to this, it's just the other way around, and multiplication is commutative, so it's the same answer. And there you go, that's how to factorise by what's called grouping. And this is the technique we're going to use throughout the remainder of the video. So let's try another one. Pause and have a go here yourself. Step 1. Do 8 multiplied by 3, which is equal to 24. The question you're going to ask yourself, you're going to look for two numbers that multiply to 24 but add up to positive 10. Can you think of two numbers that do that trick for you? Well, I can. 6 and 4. Split this 10x up into 6x and 4x. It doesn't matter what way around you write it. So I'm going to write 8x squared, add 6x, add 4x, add 3, like that. Then I'm going to factorise these first two terms. The common factor here is 2x, and you would get here 4x add 3. There's no common factor of 4x add 3 other than 1. And you have to, for this method to work, actually always factorise out something. So factorise out the 1. So we would write plus 1, and we would be left with 4x add 3. Can you see that the 4x add 3 is here and here? So we can factorise that out the front, 4x add 3, and we're left with a second bracket, 2x add 1. And all the way along I should have written my identical signs, but there you go, I factorised this. Next one, pause the video, have a go. Step 1. 3 multiplied by 4 is 12. I'm going to ask myself the following question. Can I think of two numbers that multiply to 12 and add to 13? I certainly can, 12 and 1. So I'm going to break up this 13x into 12x and 1x. I'm going to say that's 3x squared, add 12x, add a single x, add 4. I'm going to factorise each part separately. That's going to be like that. The only common factor of x and 4 is 1, so make sure you factorise out a positive 1 and you get x add 4 here. You'll see there's an x add 4 here and an x add 4 here, and that can be factorised out the front, x add 4. You're left with 3x add 1 in your second bracket, and there you go, we've factorised these. Now at all stages, at the very end, if I was in an exam or doing homework, I'd multiply this out and double check it's equal to that. But I'm doing these right, I know that, but you should always check. Next one, pause and have a go. Step 1, 4 multiplied by negative 6 is negative 24. Ask yourself this question, can you think of two numbers that multiply to negative 24 and add up to negative 5? I can, negative 8 and positive 3. So I'm going to break up this negative 5x into negative 8x and positive 3x. So I'm going to say this is identical to 4x squared, subtract 8x, add 3x, take away 6. And then I'm going to say, right, factor this bit separately. That's 4x, x take away 2. And here I can only factor out a positive 3, but again I get x take away 2. I always get the same bracket here, which I then subsequently factorise out the front. and I get x subtract 2, 4x add 3. I'm done. Times it out if you're in an exam and check, but I know this is right. Next one, pause, have a go. 6 multiplied by 3 is 18. Ask yourself this question. Can you think of two numbers that multiply up to 18 and add to negative 19? I can, negative 1 and negative 18. So I'm going to break this up. I'm going to write 6x squared. I'm going to subtract 1x, which I'll just write as x, subtract 18x, add 3. Let's factorize these separately here. X is the only common factor in here, and I'm going to get myself 6x take away 1. Now here, you've got to be careful. You want the other bracket to be 6x take away 1. So I can factor out a 3, but also, because that's negative, factor out a negative 3. If you factor out a negative 3, you'll get 6x take away 1 in the second bracket. You always want these to be the same. And so this would factorize to 6x subtract 1, x subtract 3. Before you move on, multiply it out and double check you get this answer. And we're done.